And the other reason that the connection is available widely throughout this country and the rest of the world. We found out that even in South Africa, they have this implant and they have this connection. So I was thinking, and I do happen to have one patient from South Africa, that if that one patient ended up needing something on my implant in her original country, I can have her go to a local dentist and ask for an Astra Aqua connection, and they will be able to help her with that connection. So I adapted that one connection, and we made sure all our implants fitted, and that individual connection is strong enough for all the situations. And those of you who are familiar with the 510K process, we need to make the weakest combination of our abutment and implant. In our case was the 3.5 implant with the 20-degree angled narrow platform abutment. So we had that weakest connection made, and we made 20 of it and gave it to a FDA approved laboratory for fatigue testing. And in that they hit it 5 million times with the special instrument, and then they call it run out. What the run out is, in other words, how many times they have to hit it till it breaks, or when they hit it 5 million times, at what load does it break? It's a whole complicated thing. The result is like 18 pages of report. But what I mean is, we made sure that our design, and with this connection, withstands the use of the implant all over the mouth, even the back teeth. And I must say that our first design did not qualify. We didn't bother submitting it because it wasn't up to par. In other words, the first time that I had these implants, the way we had designed the grooves and the vertical flutes and all that, the implant had a fracture issue here. So we went back to drawing board, redrew it, beefed up the implant, remade the implant, retested it, and this time it came with flying colors, better than average of all the implants which are out there. And that's our smallest, narrowest implant. So we have made sure that this one connection can withstand all the loads that are customary to be borne by all the back teeth. Other than that, as I said, this another feature that I put in there is this negative curvature here. I know one of the brands, Ankylos, they brag about one of the features that when their implant is placed subcrestal, the bone would grow over it. And that will make sure that this implant stays in and doesn't go anywhere. And I've seen x-rays of that happening. And it's an impressive feature. It's very impressive to be able to place an implant and be sure that you're not going to have a crestal bone loss, because that is the major problem with dental implant systems. So I created a similar thing, but much deeper. So all my implants have this negative angle, but instead of being a bevel, it's actually a negative angle. So it does what the Ankylos does and more. And then we have subcrestal placement protocols. So we have all healing caps and abutments for subcrestal placed implant. And I must say, for the dozens of cases that I have done in the past few months, I already see that as this is healing, the bone is actually healing into that space. And if bone heals here, that is the best situation you want to have, because this is where the bone loss occurs. And all these implants that come straight up like this, the most vulnerable part of the implant, the bone is the thinnest. Here, the most vulnerable, the bone gets thicker. I mean, that's the whole idea of the subcrestal placement. So that's what I mean by, oh, another thing, we had cylindrical implants and then root form tapered implants. Now this is not cylindrical obviously, but it's not your regular taper either. Regular taper is from here, straight line down. This follows a specific algorithm that as this implant goes in, each of these blades takes a small percentage off of the wall, and the speed that each of these take the bone from up here to the bottom is equal. We did a lot of mathematical calculation as to how to curve this so that the speed that this blade takes the bone is the same speed as this blade. So this follows a very, very specific mathematical algorithm which is uniform in all our three dimensions. So unlike some other companies that have different shapes or different sizes, we have the exact same shape. Everything follows a formula. How much of it be curved, what kind of curvature, how much of it be flat, that's a formula that we have it on 3.5, 4.5, and 5.5. It's the same formula, same principles. It's on a larger scale or smaller scale. And our longer ones, same thing. They follow the same formula, the algorithmic formula. That's why in our, for instance, 14mm implant, you'll see a much greater curvature on the bottom of it, but it comes very, very parallel as it comes up. It's all following that formula that there's equal amount of bone being taken and pressed into these vertical grooves by each of these blades of the implant.
So if I am an implant-only certified dentist and I have a new consultation and the patient comes in and you say, hey, I have this new dental implant that I'm using, it's better than the others, how do I convey that to the patient? What do I tell them?
First of all, you're having a dental new implant system, implantable system. The implantable system has a lot of advantages that other systems still don't have. As of today, which is April 12, 2016, there is no company in US that has stock abutments for friction grip system. We are the only one. As of April of 2016, no company in United States is offering stock abutments for a friction grip system. We are the only one.
Well, I just need 1, 2, 3 place.
Okay, for the 1, 2, 3 placement, the advantage is we have variety of stock abutments that your dentist can choose from, so he doesn't have to order a $800 custom abutment for you. So we can, instead of $800, he spends $100, and your implant is $700 less, just because we can use those abutments. Number one. Number two, this implant takes advantage of every square millimeter of the implant to give you a more stable, longer lasting implant. The other implants, for the reasons I just mentioned, they will work, but so does a mule work if you want to go from here to the valley. But is that how you want to go? If I said that, hey, you get on this mule, you'll be in the valley by tonight, and most likely you will be. But isn't it better to sit in a latest car and just put your foot on the pedal and get to the valley if you want to go there? So this implant is that car compared to the other implants that are that mule. They'll work, it's just not working as good. There's always chance of failure. I'm sure my implant has failures too, but we don't have the proof yet because we haven't been around that long for me to prove it. But because it uses every square millimeter of it to a physical advantage that we know of, the chance of success must be higher. It just makes sense that it's higher. You don't have to prove it. If you know, for instance, flat tire blows quicker, we know that. So if you have a tire with the thicker meat of rubber on it, it just makes sense for you to imagine that, okay, it should last longer than a tire that has quarter of that ring. I mean, you don't have to do studies to find out, okay, this thicker rubber meat on top of it will make the tire last longer. We already know that. So I'm not saying this as a matter of fact because we have not been able to establish it, but as a matter of common sense that you hit your thumb with a hammer, it's going to hurt. You don't need studies to prove it. Based on what we know of how hammer comes down and how sensitive our thumbs are, we know if it hits it, it hurts.
To that point,